One of the most important ideas in the evolutionary paradigm is the idea that life comes fundamentally from non-life. The idea here is that a complex chemical mixture underwent self-organization to generate the very first cells. This is also called abiogenesis, or chemical evolution. And this idea was first proposed in the 1920s by two scientists, Alexander Oparin, a Russian biochemist, and J.B.S. Haldane, a British geneticist, and is also known as the Oparin-Haldane hypothesis. And the idea here is that on the early Earth, the environment was very different than today. And on this early Earth environment, simple chemical materials underwent chemical transformations stimulated by energy discharges, let's say in the atmosphere, like lightning, that drove the production of small organic materials that accumulated in the Earth's oceans to form this well-known prebiotic soup, a primordial soup. And within that soup, chemical reactions continued to take place that began to produce ever increasingly complex molecules that began to associate with each other to form protocells that then evolved to give rise to the very first life form. And that once this life form was in place, it in turn began to evolve to produce the evolutionary tree of life. And so the idea here is that the origin of life, abiogenesis, chemical evolution, is a critical and important idea in the evolutionary paradigm, explaining how life itself got started from an inanimate, non-living universe. Now, justification or validation for this Oparin-Haldane hypothesis came in the early 1950s, according to scientists, when a young graduate student by the name of Stanley Miller, who was at the University of Chicago, did the famous Miller-Urey experiment that shows up in every biology textbook. And what Stanley Miller did was went into the lab and assembled a glass apparatus that was rather elaborate, that was supposed to simulate the conditions of the early Earth. He had a beaker of boiling water that was supposed to simulate the hot temperatures of the early Earth and the boiling oceans. And that boiling water sent steam into the headspace of his apparatus. He was very careful to make sure no oxygen was present in the apparatus, and then he introduced methane and ammonia and hydrogen gas, believed to be present in the early atmosphere, and then had a continuous electrical discharge going through that simulated atmosphere, and over the course of a few days noticed that chemical reactions were happening in the apparatus, and was eventually able to show after a few weeks that amino acids formed in this system. Amino acids are the building blocks of proteins, which are very important life molecules. And so people believed at that time, and even today, that Miller's famous experiment validates the Oparin-Haldane hypothesis, makes it scientifically reasonable for abiogenesis to take place. But what's interesting is this, and this is something that doesn't show up in biology textbooks, and that is that the atmosphere that Miller simulated in his experiments, supposedly representing the early Earth's atmosphere, is not the atmosphere that we now know existed on the early Earth. Miller thought the atmosphere consisted of water vapor, hydrogen, methane, ammonia. Well, it turns out that the atmosphere actually consists of, in the early Earth at least, consisted of carbon dioxide, nitrogen, and water. And those gases, if you put those in the Miller-Urey experimental setup, as opposed to methane, hydrogen, and ammonia, those gases don't generate amino acids. In fact, they don't generate anything at all. It's a chemically inert, a chemically non-reactive system. And so, in other words, the Miller-Urey experiment, which supposedly validates the Oparin-Haldane hypothesis and the idea of abiogenesis and chemical evolution, is not relevant because it doesn't appropriately simulate the conditions of the early Earth. And in fact, Stanley Miller had two long-term associates who worked with him throughout his career as a scientist, who said this in light of this new evidence: is the prebiotic soup theory a reasonable explanation for the emergence of life? contemporary geochemists tend to doubt that the primitive atmosphere had the highly reducing composition used by Miller in 1953. In other words, the scientific community no longer thinks, at least some people within the scientific community who are in the know, no longer regard the Miller-Urey experiment as justification or validation for the apparent Haldane hypothesis, but rather only view it as being historically important because it did stimulate further work in the origin of life question. But again, the Miller-Urey experiment is not justification or validation for this idea that life comes from non-life. And in fact, a critical component of chemical evolution, of the origin of life scenario, is that life comes out of a primordial soup. Well, if this primordial soup, which supposedly spawned life, existed on the early Earth, we should be able to demonstrate scientifically that that is true by going to the oldest rock formations on Earth, which date at 3.8 billion years, and look for a chemical signature that this soup would have left behind. And the fact of the matter is we see no evidence in these oldest rock formations for a prebiotic soup whatsoever. The prebiotic soup, the primordial soup, is essentially a scientific myth. It is not an established scientific fact. Noam Layev, an origin of life researcher who wrote a book called Abiogenesis, said this: "So far, no geochemical evidence for the existence of a prebiotic soup has been published. Indeed, a number of scientists have challenged the prebiotic soup concept, noting that even if it existed, the concentration of organic building blocks in it would have been too small to be meaningful for prebiotic evolution." There's no evidence that a prebiotic soup ever existed. The Miller-Urey experiment is an interesting scientific experiment, but it doesn't have any relevancy to the conditions of the early Earth and therefore is not evidence for chemical evolution. Chemical evolution, the origin of life scenario, abiogenesis, is a critical component. It's a cornerstone idea in the evolutionary paradigm, and yet scientists cannot establish with any kind of scientific certainty that life indeed came from non-life through this process of chemical evolution. And so if a Christian takes the view that God is responsible for creating the very first life forms, that is a scientifically reasonable statement. That is a scientifically reasonable position to take because scientists cannot demonstrate the origin of life happened the way they think it happened through undirected chemical and physical processes.